Welcome back to TrueNAS Tech Talk. Today's episode is all about virtualization and containers. We've got Docker, LXC, and KVM. So what's the difference and which one's right for you and your workload? We'll also handle some of the Q&A that came up from our last technical-based shows. Stick around.
This week's episode brought to you by our sponsor, TrueNAS. Of course, we want to continue to bring you this content on a regular basis. You can help with that by doing the usual YouTube things, like, subscribe, and please do share with your other technical friends. Otherwise, I'll be forced to make us switch sides on the video again, and you don't want that.
So, Chris, we've been asked to dig a bit into the differences between the three types of virtualization or containerization that are going to be available in TrueNAS, especially with the upcoming changes to containers that we're doing in TrueNAS 26 with the change to libvirt there. So how about we do a little bit of a recap? I know we did this, back in the day. I forget if it was episode 16, 17, somewhere in there in the late teens, we talked about it, but it's worth revisiting now with some of the changes that we've gone through in the technology. So
yeah, a year ago, that's a lifetime. Technology moves fast, right?
Oh, absolutely.
Things are changing. So no, it's good. It's time to do a recap. And I guess timing's right as well, since the change to libvirt. This kind of brings the trifecta back. We mentioned this on last week's episode about having not only Docker, but then LXC style containers powered by libvirt. And then of course, our standard KVM, traditional VM. So we'll take a moment. Let's deep dive through that and kind of do a little bit of an explainer about how they are similar, where they differ, use cases for each, all that good stuff. So first up, let's get into the kind of main technology differences between them. So this is going to be interesting because in some cases, certain ones will overlap, in certain cases, others won't. So pay attention, buckle up. So of course, Docker and LXC, they're going to be both very similar in respects to how they containerize applications and services. These are more Linux native virtualization technologies. They're built on top of Linux. They use C groups. They use other kernel level containerization primitives. So if you've been around a long time, you've ever used tools like chroot, which is a way of like putting yourself in like a different virtual environment. Think of it as that on steroids, right? It's up with all the extra functionality enforced at a kernel level for enforcing isolation between what you're doing inside this new container environment and then outside what the host is doing. And what's beautiful about it is the host, you can always peek into the containers. You can see inside and see what's going on and introspect. You can run PS from the host, see what processes are running in your containers. That's something you wouldn't see in, say, a traditional VM. You're not able to, at the Linux host side, be able to go and see what's happening inside a Windows VM, for example. They don't operate at that level.
Exactly.
And then on top of it, you have the networking differences as well, because inside the container, it has its own virtualized network stack. It's very lightweight, but it's not emulating a full, network interface as well. So it's quick, it's fast. So in this respect, LXC and Docker is very similar. But what is different is when you get into how they treat things like permanence and updating. So this is an important thing, and I think some folks kind of gloss over this or don't really understand it when they first start playing with these technologies in TrueNAS for the first time. A lot of people, this is their first exposure. So Docker containers revolve around the idea that you're going to run a container, which is more of an ephemeral environment. What do I mean by that? What I mean is you're getting an image, downloading it, you're deploying it and running it. Changes made inside that container image can be lost and thrown away at any time. Basically, when you restart the container, when you update, if you've made changes inside that container environment, you've made changes in different directories, guess what? Those are lost. Now, you might be thinking, oh, that's terrible. I want my changes to persist, all that. Well, do you? Yes and no. There's pros and cons to this approach.
Sometimes you don't. Sometimes you have a bunch of, temporary data or cache data, Everybody remembers back in the day, you would clear out your temp files and your temporary internet files to free up space on a limited machine, or you thought it made your system faster because you would get rid of this additional files you didn't need. Well, you're probably just clearing cache that's going to have to regenerate anyways. But sometimes you don't want to keep this configuration around or this sort of temporary setup, or you want the ability to easily sort of do that reset back to factory.
Mm-hmm. Well, this is an important component in how Docker containers do their upgrade lifecycle management. So for example, if you need persistence, apps that are packaged into Docker containers, they achieve this by having this idea that you'll have maybe one target volume mount or maybe multiple. Sometimes there's a bunch. But there's this notion of there are certain locations from within the container's perspective that you can store data safely that will persist across restarts of the container, okay? So this means your upgrade mechanism is very clean and nice and tidy. So for example, I have an application. A lot of times applications will have a small configuration file, maybe a database, and that's really the only piece of data that needs to persist apart from, other data pieces that you're working on, which can be mounted in from the host. We'll get into that later. But what it means is your upgrade vehicle is very simple. You download the new container image, you restart it, the application inside the container starts. It says, oh, here's my persistent database. Ooh, this is from a previous version I was running. I'll do some update mechanisms, some housekeeping. The application handles all of that. You're not having to, as a developer, go and write an application, which is like, yeah, but what if they made changes to system D or they changed the runtime environment in Etsy or no. All that's taken care of by the container. What you ship is what the customer will run, what the user will run. And so from a developer and kind of a deployment perspective, Docker containers are fantastic for that, as long as you can live within the certain constraints of I only am going to have data that's persistent placed in certain locations from within the container. Now, where that lives outside the container could be anywhere on the host, on your pool. You have different ways of sharing within the ZFS hierarchy. Of course, we have IX volumes we can create. You can map in artificial locations, et cetera. But that's part of the flexibility.
Exactly. You can map in your, a memory device if you want to back something in cache. You can have a hard drive pool and a solid state pool. I know a lot of people who run image do that.
Mm-hmm.
My bulk data lives on hard drives. My thumbnail generation goes to an SSD, and they say, hey, I've got the best of both worlds here. Or for your generic app, you've got like a config folder, a DB folder, your bulk data. You say, well, hey, config should live on SSD. Data is going to live on SSD because those need to be quick random access. But again, put my bulk data somewhere else. And it doesn't matter what your pool's named. It doesn't matter, what subdirectory or sub data sets you've got it in. As long as inside that container, you've got a mapping that says, hey, I've got /app/data. I don't really care where it lives outside of that.
Yeah.
Just map it in there.
So it's just a location with files at that point. Doesn't need to know anything more than that.
Yeah. A little bit of a walled garden, sometimes people say, but, walled gardens can sometimes be kept really pretty because, you don't have everything coming in from outside. So
biggest thing is they don't tend to break on you as often.
Yeah.
But so
After
this is
Docker.
where we get into the difference. After Docker, right, you start getting into LXC. So LXC is more like your traditional VM environment. Think of it as a full-blown OS. So the entire container stack, the entire on-disk files are 100% persistent, meaning if you install Debian, you have a full-blown Debian environment. You can make changes to everything and anything inside that environment at will. It means you can do systemd things, you can install new packages, you can update config files in Etsy, splat things here and there. It gives you ultimate control over the environment, a la a VM, but not quite the same as a bare metal, much lighter weight in the sense of there's no kernel. You're still using your host Linux kernel. The network interface is going to be much faster. And more importantly, the disk access is going to be far, far faster as well. We'll get into performance a little later, but it gives you that ultimate flexibility and tweakability. But the onus is on you to administrate it like it is a full-blown bare metal Linux environment, right?
Yeah. Again, you want to do that persistence with there. If you want to have selective persistence and say, hey, I don't want to have to do a manual backup from within my container to somewhere else. You're having to do that volume mapping just like you would with Docker. If you, paint yourself into a corner in your LXC and you go, oh crap, it won't boot. You're going to have to go and extricate that yourself. You can't just blap your whole container and start again, or you'll lose all that data. So
a
little bit,
gotta be willing to set it up by hand again.
Yeah, a little bit more flexibility, a little bit more responsibility. So then after LXC, which is closer to virtualization but still running your host kernel, your next step, of course, Chris, is a full VM backed by KVM.
This is what you think of as traditional VMs, right?
Yeah.
This is where you run anything that's not Linux. You run, your entire virtual hardware environment, which is either emulated or para-emulated to give more performance. But that's the maximum flexibility because you can run whatever OS, whatever software stack you want. Doesn't have to be Linux. Can be a different version of Linux with a different kernel version. All those good things. So that's your traditional virtualization. But as I mentioned, Docker and LXC are going to both be restricted to running native Linux things, which is fine. For most services you're running on TrueNAS, there is a Linux version of it, and more things these days have Linux. There's very few things I run into where it's like, I need Windows to do that, right? Or if it's on BSD, it's always on Linux. So very rarely it's like, that's BSD only. That's not a thing anymore. But I'd recommend, of course, you stick with the Linux environment and use a lighter weight virtualization. But sometimes you need that flexibility. There is that legacy app. It's a Windows only thing. It needs to talk to some device on my network. We see that occasionally. So I get it. You just have a higher cost with regard to CPU memory and disk IO.
So obviously this begs the question. We've got these three different versions of containerization and virtualization. If I can use any of them, is there a particular preference order that I should use that, I should prefer to run my things in? So what would we suggest, Chris, overall for, our TrueNAS user base?
Well, I'll make it simple. And again, feel free to disagree or argue with me in the comments, but I'd say you start with Docker first, then you go to LXC, and then last but not least, you go to full-blown KVM VMs. So why? Well, Docker, first of all, is going to be best if you're just getting started. If you're a newbie and you just want to be able to click some buttons and deploy an app and have the best shot at it just working, that is your best bet. But don't let that fool you. It's not just for newbies. Like if you are an experienced admin and you just don't feel like you have the time to go mess with manually updating containers, having to go basically administrate Debian by hand or some other Linux variant by hand. Have to use their native packaging system, their update mechanisms. And I did an update and my database version got changed and now I need to go change things again. If you just want that set it and forget it experience, Docker containers are still your best bet. Now, granted, not everything will run in a Docker container, but if the target application you do want to run is available as a Docker container, highly, highly, highly recommend you start there. Because once you kind of get it tweaked and dialed in, then it means later when you come update time, which it seems like there's updates to these apps daily, if not weekly half the time, you can just go click a button and get back to your day. Like again, I used to run extensive jails in the BSD days, right? I had jails set up for Plex and all these different things. Updating was a weekend chore. It was not fun. Like it was like, I'm going to set some time. Things are going down for a bit. I got to go do package updates. And this one didn't build right. I got to build something from source. It was messy. It was not clean. And then I took the work, converted everything to Docker. And now it's like, I just click the update button. I don't even monitor it half the time. I just walk away and like things come back. Yeah. So that's where I would recommend starting.
Yeah, that's the kind of containerization technology I really wish existed back when I was primarily a Windows admin and I was fighting with, different versions of like the Java JVM or JRE runtimes in there. That's the kind of stuff that Docker would just solve for you in that kind of world. You say, hey, I have a very specific version of this sub-library that I need. Well, it's going to get packaged with that Docker container. You can have a different one that exists on a different Docker container and never the two shall meet. It's fantastic for that.
I've even gone to the extreme in some cases, Chris, where there wasn't a Docker version of something. And I went and actually just built the Docker version myself, hosted it and built it myself, just so I had that flexibility of it's super easy for me to push this update out to my couple TrueNAS boxes. They can click update, life goes on. Like it may be even worth learning how to do that if you're more interested in digging in. But beyond Docker, say Docker is not a good fit for whatever reason. The package isn't available or you do need more flexibility because you're going to do a lot of custom stuff. So LXC is, of course, going to be your next step and where I'd recommend you go. If you need the more full-blown Linux environment, you need the ultimate flexibility administrating everything custom, you can absolutely go do an LXC environment. So where an example of this may be, I have a service I want to run or I have a bunch of services I want to bundle together in one container. So for example, an entire stack of things that has not only a web stack, but a backend database. And I want to go pick the pieces and stitch them all together to work in one kind of cohesive system, a la VM. Do it in LXC. Why not? You get that flexibility.
And then last but not least, I mean, if you got to run outside the world of Linux, this is where you need to go with KVM, right, Chris? If you're not even just if you're running a different OS, but maybe something that doesn't want to run or can't run the same kernel that TrueNAS is using under the hood. If you need to run, a newer kernel or a different kernel or older kernel, then KVM starts to be your only option at that point. And I think Home Assistant OS is one that you run there. That's our good example of that. It's still Linux, but you got to run a different kernel.
That was going to be my example. That's the one that kind of bums me a little. It's a shame they don't have the LXC or Docker version. I mean, they do. They have a Docker version. The LXC version they deprecated a while ago. But the full virtualized version is the only one that supports their ability to install add-ons and plugins and do other stuff and just makes it convenient. So that's the exception where I say, okay, I'll run this Linux thing, even though it's probably perfectly capable of running on the host. And I've seen some of you do it. So of course, you're welcome to link to your tutorials and guides on how to do it in LXC by hand. Who has time for that? In this case, it was just easier to deploy the VM and just not have to fuss with it, right? Because you're back in the jail world where it's like, oh, now I want to do an update. I'm doing it all by hand, and this broke and that broke, and there goes half of my weekend. So I don't want to do that. But again, if I have to run a Windows thing, if I have to run any other version of a OS, KVM is still where you're going to go to, and that's your fallback for everything else.
Okay. And one of the things that people like to ask about virtualization is they say, hey, if it's this easy to get something up, and especially with Docker, where we're talking about like these ephemeral workloads, we have highly available systems with TrueNAS Enterprise. So we have our HA, dual controller with storage failover. How does HA intersect with these things where we're doing like compute on top of it? Do we have the same level of HA, or is this something a little bit different?
Well, so HA, you have to think of it as a compute node. If you were running a VMware environment, for example, and you had compute nodes, if a compute node went down, your workload would come back up on another compute load. It would look like the application had crashed and been restarted, or the VM had been crashed and restarted. It's the same thing in an HA environment because you're basically switching from one compute node to another. So if you have to do a failover, what's going to happen is your Docker apps will get restarted, your LXC containers will get restarted, or your VM will get restarted. And that's how it goes. Now, if it's a planned failover, something, of course, you can shut down things cleanly and make it all nice and all that. But if it's unplanned, I mean, essentially, that's obviously a crash, just like a VMware node crashing out on you.
Yeah, it's the difference between high availability and fault tolerance. Fault tolerance in that world is where you are literally running the workload on both sides in lockstep. And obviously that's limited by, that interlink speed. RAM runs in, dozens of gigabytes per second, unless you have an interlink speed that's that fast. And then you still have to deal with the latency of going in there. RAM goes in, nanoseconds. We're not quite there for a lot of network. They're still measuring in microseconds. Some of them some are getting there, but
there's a philosophy thing to really talk about here too. There's a lot of folks who prefer to do this at the application layer. If you need true fault tolerance, that does make more sense. Are you better off trying to make a full VM OS and all the packages and all the libraries and all the things behave well in a fault tolerant type setup? Or are you better off getting a targeted application that does it at that level where it says, yeah, I'm running in clustered mode and I'm fault tolerant in the sense that any one of these nodes can go down and life goes on and clients are happy. So that's, I think, what you see more often in the real world, even running in VMware. You'll see people running application stacks that are very fault tolerant and they kind of handle it at that layer.
Yeah, exactly. Fault tolerance in that world is really meant for more of those older applications that are, on life support. They're kind of in an archived, unsupported status, and they were like, "Hey, this thing uses one or two cores, maybe. It's never going to become a clustered application by the developer because maybe the developer's been out of business for 10 years. But we want to give it some additional measure of fault tolerance." That's where they put it down, and you do your clustering or your HA, so to speak, down at the actual level of an emulated set of hardware and a kernel. Way more overhead with that, but hey, we're talking about overhead and performance, so that's a great segue. How do these three different, containerization, virtualization methods stack up when we talk about, RAM, CPU, disk performance, things like that?
Well, I hinted at it already, but let's dig into this a little more. So Docker and LXC are both going to be the lightest weight thing you can run. They're going to be about equivalent performance, and that's because at the end of the day, they're running on the same host kernel. It's a highly virtualized container environment. They're not having to emulate things like a network device. They're not having to go and pass through a whole CPU. They're not having to run a whole kernel, which is doing its own scheduling, has its own memory management, and all that. And that's before we even get into the most interesting part of what you see on TrueNAS, because we're a storage device. This is, I think the thing people don't always appreciate is the storage speed hit you take going to a full-blown virtualized environment through KVM. When you run in Docker and LXC, you're able to pass through locations on your pool natively to that container using what essentially is like a nothing mount point. It's just a redirect. The kernel just says, oh, you opened a file, your file's actually over here, here you go. There's no network layer to go through. There's no translation I got to do. There's no protocol. It's just, here's a pointer to your file, and the performance, it's pretty much negligible.
Exactly. Like on KVM, you go, hey, this system wants to open a file. Well, it thinks it's opening it on a disk. It's got to go through a translation of protocol, probably through a SCSI driver to say, hey, I'm looking for this LBA. But then you're mapping this into like a ZVol on ZFS, which is then going to map it to a different LBA. You know, we talked about NVMe over Fabric being introduced in 2510. That talks about chopping out all of those different protocols. When you do stuff like KVM and you have emulated storage controllers, you've suddenly just stacked a bunch more intermediary layers in the middle. And each one of those is going to have that little bit of penalty, even if you're running it at, CPU level clock cycles in the nanoseconds. It's going to add up eventually. Everything's got to be that call and answer back and forth between them.
It's extra memory copies. It's shuffling bits here and there. It's putting things into a network stack. Well, so that's the piece we didn't really get into. So in the case of mapping a ZVol, and sure, that's going to show up as an emulated disk. But a lot of times people say, well, I want to run a VM, but I also want to access this data I have on my pool in a data set. And so you end up resorting to doing SMB or NFS, sure. So if you're running a Windows VM, you have to do that mount. You have to bring it in over SMB, which makes sense and it works. And it is faster to run that on the storage host directly and talk to it without actually going over the network. But there's still a virtual network in there, even if you use VirtIO. Like there's still some level of virtualization happening there. And kernels are doing extra work. Mem copies are happening.
You're packing up your traffic into SMB and then inside TCP and then just have to disassemble it on the other end. You added so many intermediary layers in the middle, but that you have to go through. You could just take them out, wherever possible.
At the end of the day, bottom line is, if it is Linux, if it's native, if it has a Docker container, if it can run in a Linux environment, you're almost always better off running it inside LXC or inside a Docker container. And again, Windows VMs are there if you absolutely have to fall back to that. Just understand there's a penalty for doing so. Now, your workload may not care. It might be that you're really compute bound and you're just doing crunching of things and the storage isn't really a bottleneck.
Exactly.
Cool, fine. Again, every workload's different. You'll always find exceptions to these kind of rules of thumb. But that's what they are, is rules of thumb. We're trying to provide the best possible guidance to the widest group of deployment scenarios here.
Well, now you got me curious for my crazy experimentation. Is I'm going to load the OpenZFS for Windows build and see if I can actually bind mount into a Windows VM. We're going to do some storage heresy over the weekend here, folks. So I'll see if that works out. If I'm not back or my video is really blocky and I had to reformat, you'll know what happened.
Yes, for science.
Absolutely.
Have fun.
But hey, we're talking about network protocols, network layers. That's one thing that people have asked a lot about, to say, hey, how can I do these different things with, my apps? I want my apps to be, tunneled in or out through a certain IP. I want to route them all through a different gateway. I want to put my my certain applications, whether it's Docker or LXC, I want them all to pipe through a VPN for some reason. Guys, we know what you're doing with that, but it's about your privacy. I completely understand. You want to have your privacy on the internet. So we understand why you want to route certain apps through a VPN all the time. So how would we do that?
Yeah, we'll get into that. That's interesting that you asked. But one of the things we should probably clarify a little bit beforehand is kind of the basic setup of networking between the different three options here, because Docker is going to be a little different. This is where LXC and now your VMs are more similar. So with Docker container, you're usually going to go down the route of not setting up specific IP addresses bound to the Docker application you're running. Instead, more often than not, you're going to be mapping ports from your existing TrueNAS IP addresses to an internal container IP address, which are managed in the background by TrueNAS and Docker for you. So internally, your Docker containers are getting virtual IP addresses. You don't even know or care what they are half the time. And then externally, you're picking what ports you want to expose. So for example, you deploy three applications, they all have their own web interface, as a lot of them do these days. They might all just assume, well, I'm going to serve that over port 80 inside the container. Well, now you got a problem. You can't expose port 80 on the TrueNAS management interface. You might have the TrueNAS UI running there for number one. Number two, all three of them want port 80. So you end up remapping things on the host side to say, okay, well, I'm going to use port 8080, port 8090, port 9080, and I'm going to map those to my three separate applications, all sharing the same TrueNAS IP address. And when I want to go hit that application's web interface, I just have to remember what port it's running on. That's more typical in the Docker environment. Now you circle back to LXC and KVM. In those instances, you're giving it an IP address per container. or per VM in this case.
Yeah.
You have all the flexibility inside there. You want to run different applications all on port 80 in their own VMs, you can do that. And on the network, it'll look like I just go to this IP address. I have port 80 running. I can hit that. Standard HTTP works, or you can do 443 for HTTPS, however you want to set it up. You can, of course, get fancier, put Nginx Proxy Manager or Caddy and other things in front of it to serve certificates and make everything nice and over TLS. That's good. But at a broad level, those are two things you should be aware of when you're deploying is, do I really want a bunch of extra IPs on my network for my services, or am I comfortable sharing with the host? Now, Kris, tell me about what would you recommend for people who want to go and do something a little more complex and say pass traffic through a VPN for no reason whatsoever?
Something like that, you can create the additional IP on your TrueNAS host, for example. Like if you say, I'm going to create a second IP and I'm going to have this one specifically on a different subnet, I probably want to have my VPN concentrator outside of my TrueNAS so that I know there's not a dependency on TrueNAS running and everything working and routing properly in there. Mm-hmm. That way there's no chance for you accidentally getting, a gateway wrong somewhere or a traffic sort of leaking from one to another, or a DNS leak. Basically say, if you're really that concerned about it, that's almost where you're going to say, I'm going to run like LXC in a separate container. I'm going to forcibly do my tunneling inside there. If you want that full level of control over your network stack, use something that makes it more native to give you that control. Running it as a Docker app and saying, I really want this Docker app to go here and this one to go here, but then sometimes you're going to want to have them talking to each other internally. Yeah. You're starting to make a bit of a complicated web. I think we had a support ticket or kind of a feature request a problem come in, something on our Jira, where somebody was actually running like a pfSense gateway in a VM on TrueNAS, and they then wanted to have their apps going through that gateway using VPN tunneling. And at that point, you've really got kind of almost a recursive loop of dependencies there. It made it pretty awful, because one of the things we do for sanity checking is we're going to wait till your network interfaces are up and that you've got IPs assigned before we want to start all your workloads. But we couldn't do that because your pfSense is running in a VM.
Yeah.
The VM would eventually start on its own. And after a 5-minute delay or something, you could forcibly restart your entire app service and remount everything. Yeah. But
this is the classic mistake people make with Active Directory, Kris. Yeah. We've had a handful of folks say, "Oh, I want to run my Active Directory as a VM on TrueNAS."
Yeah.
And then I want to bind TrueNAS for sharing. But there's a dependency problem. We have a little chicken egg problem here, because when the system boots up, we need to be able to bring up the sharing protocols before we bring up the VM containerization workloads. Why? Well, a lot of times people are using those sharing protocols in the VMs to mount storage. So it means I have a dependency problem now. I can't bring up the sharing protocol because the Active Directory is unavailable. And the Active Directory can't start because the sharing protocol is not started.
Yeah.
See what I mean? So
as soon as you start adding things that loop back to TrueNAS itself in this manner, it becomes more and more complicated. I know we had people who said, hey, I have a VM that's got an NFS mount back to TrueNAS, and when I tell TrueNAS to shut down, kind of everything tears down all at once. And hey, can we get this additional order of operations to say, if I've got this VM running, I need to bring down the VM first and then my NFS service and then other things. The more you create these dependencies, there's a reason that they coined the phrase DLL hell back in the day, because you had a lot of these, interdependencies going on. The more complicated you make these things, the more opportunity you give them to break. Now, I'm not saying we're not going to try and fix and make as many things possible as we can, but we do have to kind of look at it like, where's the effort need to be most keenly focused here. And sometimes, especially for, core critical parts of your network, whether it be, your gateway, your DNS, your DHCP server, having that running as a VM on something that depends on those services is probably not the way you want to go about it. Yeah. So don't run your pfSense or your OpenSense VM on TrueNAS and then make TrueNAS dependent on that.
Well, I can already hear the comments though, Kris. But I can do it. I hacked it. I found a way. Oh, yeah, of course you can. You can always bubblegum and spit, baling wire and do all kinds of crazy stuff.
There's a saying I like to do is I could juggle chainsaws too. It doesn't necessarily make it a fantastic idea, and I may not be able to do it for too long, and the results might be pretty ugly when I make a mistake. So Try not to juggle chainsaws, folks.
It's why we have the whole KISS principle in engineering. Keep it simple, stupid, because more often than not, the simpler solution is the right one. Now, don't get me wrong, there are times and places for complexity, but you do your best to avoid those and try and engineer not using those kind of solutions, because you're just opening yourself up to a world of hurt where it's like, oh, now I have these 18 other edge cases I didn't realize I exposed by doing this. And next thing you know, your product's all complex and buggy, and I can't test every scenario properly. So again, yes, you can do anything you want. Yes, you can run any way you want. Feel free to post your links to all the crazy setups you have in the comments. Hey, they're amusing. I enjoy watching them and seeing what people have come up with, but doesn't mean that's the best thing you want to recommend to everybody. Just imagine your less skilled friend trying to explain that to them, and then you realize you have to administrate their box for them because it's too complex. So steer away from those kind of solutions.
Virtualize responsibly, folks.
That's right.
All right.
Well, hopefully that was a good recap, and I think an introduction. We got a little deeper on a few of the topics, but give people a place to go look at, okay, where do I want to start with running different workloads on TrueNAS beyond just typical storage and sharing?
Cool. Well, hey, we've got a couple of Q&As that came in. We did ask for your questions. We've got some couple people have had some ideas, and people had some questions about, certain functionality and technical things in TrueNAS. So let's take a couple of these out, Kris, and answer them. What do we have coming up first?
First one here from dyhchang. Why can't we remove a RAIDZ VDEV from the pool like we can for mirrors or stripes? Good question.
Okay, right now upstream, that is a OpenZFS limitation. I believe the challenge with that one is whenever you have RAIDZ in there, there's some different things going on with sort of your checksums and your stripe widths. Like when you're taking things out of a mirror, it just says, it's basically able to compare A to B. And I think it's even just pulling it out, it's relocating. And I think after you do a removal, they almost suggest a scrub to say, hey, just make sure everything did come out clean off of those. And it's going to compare it. It's something that I think is one of those, it's theoretically possible, but the work needs to be, put in there and the time investment. There's also some challenges, especially when you have a RAIDZ VDEV. Now you're going to be restriping data. Because ZFS rewrite now exists, it might be possible to do something like this in that, theory crafting here. And I'm sure there's going to be a ZFS dev who's going to want to put my head on a pike for this one. But, if you tell your allocator, your ZFS storage pool allocator to say, hey, don't write anything new to this particular VDEV, the one you want to remove, and then run a rewrite effectively on this data. Would it then say, well, I'm going to try and rewrite to everywhere, but this one's been blocked? And eventually, would it sort of clear out the contents of that VDEV? It's one of those things where it's saying, again, probably theoretically possible, but the work has to be put in. And especially when you're talking about something as crucial as, relocating data on ZFS, it's one of those things that the dev is extremely paranoid about that. They don't like moving data after it's nice and stable and parity protected. So
it's one of those effort versus impact matrix questions, really. At the end of the day, there's a lot of things like this in ZFS and in TrueNAS, frankly. We all do this. Anytime you build a product or write code, you have to go look at, could I do that? Yes. Should I do that? I don't know. Is it worth it? Is there enough demand? Do enough people use this? It's really complex. And is it worth it for the one-off, I want to get rid of a VDEV? Now, again, there are valid reasons you'll say, oh, it'd be really nice if I could, but that's few and far between. That's not pretty typical.
Yeah. Special VDEVs are kind of one of these scenarios where we might start to see it more as people want to leverage those additionally in OpenZFS 2.4. So maybe that forces the issue, but again, this is something that it's an upstream dependency. It's not a TrueNAS thing. So we need to make sure that we satisfy the extreme data paranoia that runs through the core of OpenZFS first before we can turn on this kind of functionality. So our next question, Kris, comes from urulooke. I think that would be how you'd pronounce that. He says, anyone have hints on how to install TrueNAS 25.10.1 with secure boot enabled? My Supermicro board has no other OS mode that I can find. The installation manual is telling me to disable it, but can I re-enable it after install, and will it use Debian's Microsoft signed shim? Maybe I can enroll a key manually, but if so, which one? So what's the answer on this one, Kris?
No. Okay, next question. Anyway, no, well, at the end of the day, we don't have secure boot enabled in TrueNAS yet. That's on our list. It's coming, hopefully in the next release. But what we're seeing here is we have to go and basically get a shim and sign the builds ourselves. We can't use Debian's shim. The reason for that is we compile our own kernel, we compile our own bootloaders, we compile everything because we have custom versions. We don't just ship stock Debian at the end of the day. This is a TrueNAS build. It's an appliance in every true sense of the word. So to answer the question, the simple answer is no, don't turn on secure boot for the moment. Now, what will happen is down the road, you will get an update where we have started signing everything. And it is all validly signed by Microsoft signed shims, all that good stuff. When that happens, and you'll see it in the release notes and we'll announce it and all that good stuff on the TrueNAS side, at that point, you can go back and turn on secure boot. You'll see secure boot get enabled. Everything comes up. It'll look happy. Everything will be signed from the bootloader to kernel, ZFS modules, all that good stuff. So it's coming, just not yet.
Cool.
Okay. Next up, we have ANH413. Hey, I'm building my first NAS, but with the current RAMmageddon, is it possible to make do with 8 gigs of ECC UDIM? I can get those PCIe, NVMe, SSD bifurcation cards and put some Optane 16 gig on it for special VDEV. Will that help?
Yeah, RAMmageddon makes it pretty difficult to build one out of the gate. I know I've seen some people doing this on 8 gigs of ECC, ECC or non-ECC UDIMs now. So you can do it. It's just kind of the first question is going to be your performance. So 8 gigs is what we consider our minimum. You're going to be not having a huge amount of that first level, that adaptive replacement cache, your ARC. It's going to be pretty small. So you're not going to be getting RAM speed. You're not going to be getting a whole lot of acceleration out of your system with just a very small window to work with. Like maybe if you run only a single service like SMB, you might get 3.5, 4 gigs of cache usable, and that'll cache your very hottest data. Now that might be enough if you're just using it for, you're editing your Word documents. That's where you store, you're doing your taxes because it's that time of year again. But if you start leaning on there with anything heavier, like you start running apps that are going to have their own RAM demands, it's going to be a problem with that. Now, will Optane or other special VDEVs help? They're not going to help on a true RAM demand. So if you're running apps, it's not really going to help you there. For certain things like maybe your metadata, that might be of assistance, because then when you have a miss on your limited ARC for your metadata, it's at least saying, hey, I'm gonna pull it from these fast little SSDs rather than your spinning disks. We mentioned last time, I think, that L2ARC, for example, is not a complete replacement for your RAM. It's just going to be, again, it's a tiering of that performance. If you give up a gig or 2 of your primary ARC to manage, whether it's 16, 32, or even 100 gigs of your, an L2ARC, you say, okay, you sacrificed 2 gigs of memory of data 2 gigs of data that you could be reading at RAM speed in order to gain 100 gigs of data that you're going to be reading at SSD speed. Is that a trade-off that's worthwhile to you? It may be, but you also have to have enough RAM so that ARC can make the right decisions about what to stick in your L2ARC. Otherwise, if you have such a tiny RAM cache at the top, it's just basically going to be loaded, evicted, loaded, evicted, loaded, evicted, before it really has a chance to understand what has the most value to land in that SSD. You might be filling it full of garbage and you might get like a 10% hit rate on there. So it's going to be one of those things where I would say don't do special VDEVs, most likely, because those are a little bit harder to get rid of if they don't help you. Certainly try it out with 8 gigs. Maybe add an L2ARC in there, a small one, maybe 16, 32, so you don't have too big of a hit to your primary memory. Try that out. It's going to do the best it can with what it's got.
It's one of those, can you? Yes. Should you? Hard to say unless we know your workload. If you're happy, if it's a little two bay mini type system, and it's just, again, for storing your Word documents and throwing some photos and files.
If you don't have huge performance, if you don't have a huge performance demand, if you're just streaming videos and doing the odd little bit of editing, hey, you may not ever saturate a gigabit network with it, and that may be just fine. Most of, the average, the last time I ripped the Blu-ray, it came in after I compressed it at something like 6 gigs. that doesn't need to soar at gigabit to play it real time.
Mm-hmm.
All right. And our last question here comes from mantisthefirst. And this one's a little bit of a personal question for you, Chris, but you said you were willing to answer it. So you've gotten this one before. It says, Chris, are you sick or are you just on a diet?
I figured I'd answer it because I'm tired of having to answer it. So thank you for your concern. I'm not sick. I've been on a diet. I'm healthy. I'm happy. I sleep much better. So it's a good thing. No, but I'm happy. I'm good. Appreciate the question, though. Now, hopefully, I don't have to answer it anymore.
Yeah. Cheers to that. And it's a good thing to remind everybody, hey, we work a desk job, I work from home. So it's a good thing, hey, everybody, take care of your health for your own body, not just your data. Okay. Get up, move around.
Diet, move around. I'm doing a lot of yoga now. Yeah. This is great. It's keeping me healthy and active and fit. And I breathe better and sleep better. So what's not to love? There's nothing wrong with getting healthy. So
exactly. It's great to love food, but they say you can't outrun your fork, right? So
yeah, that's true.
Everybody, do the scrub of your personal body, make sure that you are keeping yourself in good condition so that, you and your data can both live a long time in the future.
Yeah, unfortunately, I don't get as much redundancy here. So
yeah, we're not all
make do with what I got.
Yeah, little Star Trek reference. We're not Klingons with the redundant organs or whatever going on. I forget what they call that. I'm not that deep into the nerd lore. My wife might know.
Doctor Who had 2 hearts and all that because he's Gallifreyan. I mean, we could get all nerdy on it, but anyway, it'd be nice. Yeah,
it would be nice.
Well, excellent. Good show.
Good show. All right. Well, hey, thanks everybody for tuning in. We had some good Q&A and we had a good little dive on the technical aspects of TrueNAS again. So again, thank you very much for tuning in. Please go ahead and do the usual YouTube things for us. Give us a like and subscribe, or else the bad stuff happens. Please feel free to submit your questions, whether it's to t3@truenas.com, in our forums at forums.truenas.com, or jump into the comment section below. Give us a little, click, a like, we'll have some back and forth in the comments. We do try to get in there and answer your questions, but sometimes if we didn't answer your question in the comments, it just means we're going to answer it on the show. So thank you very much again for tuning in. Chris and I will see you next time.